All right, this is Mr. Gilman. Today we're going to learn about complementary, supplementary, and vertical angles. Now let's take a look here. I think the hardest part about today is going to be remembering which word means what. So it's going to be important that you keep your notes out so you know what you're doing. A complementary angle is an angle that sums to 90 degrees. So two angles that sum to 90 degrees are called complementary. Complementary. Okay, when you put them together, they form a right angle. Right angle. Those right angles are also 90 degrees. So here's a little sketch for you. This is just freehand. If I had an angle like this, we'll call him angle P. And I had an angle like this, we'll call him angle Q. If I squished P and Q together, I have something that looks like this. And as you can see, if they add up to 90 degrees, then they would be complementary. Okay, so this could be like a 30 and a 60. Or it could be a 45 and a 45 would be complementary. So any two angles that add up to 90 degrees would be a complementary angle. All right, a supplementary angle actually add up to 180 degrees. Okay, they're called supplementary. All right, when you put them together, they form a straight line. So let's take a look here. If they're supplementary and they form a straight line, I could have an angle like this. We'll call him angle P again. And I could also have an angle Q, something like that. And these are just sketches, they're not perfect. But if I squished P and Q together, it would look something like this. And as you can see, it makes a straight line right here. So this angle plus this angle would have to add up to 180. So we could do something like 140 and 40. It could be like 130 and 50. We don't know what the exact measures are, but as long as they add up to 180 degrees, then they're supplementary. As you can see at the bottom there, these angles make a straight line. Okay, vertical angles share a vertex. We call them vertical angles, and are opposite of one another. Oh, sorry, two angles that share a vertex and are opposite of one another are called vertical angles. All right, and these angles are congruent. Congruent. Now, you may not have seen the word congruent before, so what it really just means is they're equal. They have equal measures. All right, so vertical angles are easy to sketch. I'm just going to make two lines just like that. And they're lines, so I said they're lines, so I better make them continuous. And the vertical angles would be this guy and this guy. Those are vertical angles. That means this angle measure and this angle measure are the same. Or this guy and this guy. Those angles are vertical, and their angle measure is the same. Okay, so as you can see, they share a vertex is what we call that. They share a vertex, and so they're called vertical. Okay, here's another sketch for you. This angle and this angle will be the same. This angle and this angle will be the same. All right, they're vertical angles. Okay, they're straight across from one another. So let's take a look at this diagram here and kind of identify some of these. Okay, some of the vertical angles. Now, when I name my angles here, since there's a lot of different letters, I'm going to name them using 3 letters. Okay, so in this case, if I'm looking for a pair of vertical angles, I would say that, oh, right here, this angle and this angle are vertical. They look like they're the same measure. They share a vertex in the middle. So I would say that a pair of vertical angles would be angle C-O-D, angle COD. Boom, right there. And angle AOE. Those would be vertical angles. Okay, now if we highlighted those, I'm going to erase this a little bit. I want to show you what are not vertical angles. AOB and DOE are not vertical. You see how they're obviously not the same angle measure. They share the vertex and it has to be a continuation. So if I put a little dashed line there, this angle and this angle will be the same. But right now, the only pair of vertical angles on this entire diagram would be COD and AOE. All right, supplementary angles make a line. So there's a lot of different pairs of supplementary angles. I see that angle AOB and angle DOB make a straight line straight across, so they could be supplementary. Make sure I get my angle signs in there. That's one thing we could write. I also see that angle EOA and angle COA are supplementary. I also see that, let's see here, what's another one? DOE and COD are supplementary. All right, so there's a lot of different supplementary angles. I'm sure there's more that I haven't labeled, but as long as they make a straight line, you see the straight line here, they make the straight line across, okay, then it's supplementary. All right, and then complementary make a 90-degree angle. So this is going to be a little harder to see on this diagram. Two angles that make a 90-degree angle. Well, I know that this angle is a straight line right here. And if I've got 90 degrees of it used up, that means there's 90 degrees left over here. So I know that the angle BOC and the angle DOC must be complementary because this is also 90 degrees. So I'm going to say angle for complementary, BOC, and angle COD are complementary. Okay? I only see one pair of complementary angles in this diagram. Okay, so it's a matter of vocab. Vertical angles share a vertex, supplementary add up to 180, and complementary are 90. Let's use this picture this time. Okay, so it's first time some vertical angles. The one that sticks out to me are these, and I think this is the only one. AOB and COD. See how they share that vertex, and this is exactly the same length or same measure as AOB. So I'm going to say angle AOB and angle DOC are vertical. All right. Let's look for some more. This time let's do supplementary. So supplementary, there's always a lot of supplementary. So I can do, here's a straight line, and I see there's angles that make up that straight line. I could do BOA and DOA, or I could do BOE and DOE. I see another straight line right here. I could do COD and AOD. That would be fine. Or I could even do COE and AOE. As long as they both add to the 180 degrees, which is the straight line, I can put those down. So there's a lot of different options that I could put there. I'm just going to put some BOA and DOA. There's one. I could also do DOE and BOE. They make a straight line. If I'm looking at this straight line, I could do this angle, angle COD, and angle DOA. And we could keep going with this, but I think you get the idea of supplementary angle. And then finally, complementary angles. The angles have to measure to 90 degrees. And these ones are the hard ones, okay? The only reason I know this is that you see that this is a right angle here. This tells me that this is 90 degrees out of my 180 total for this entire line. That means that whatever's left here also has to be 90 degrees. So I know that the two angles that are complementary are BOA and AOE. Angle BOA and angle AOE. Okay, so the complementary have to add up to 90 degrees. All right. So let's take a look at some more here. It says if we know the relationship between the two angles, we can set up an equation to solve for unknown values. And so we're going to use complementary, supplementary, and vertical angles to help us solve for the variable. So in this case, it looks to me like I have a 90-degree angle. Okay, so right away I'm thinking, oh, complementary. These two angles must add up to 90 degrees. So if the first angle is 3x, and the second angle is 45, their sum has to equal 90. Now I just have this nice equation that we practice solving every single day. 3x equals 45, and finally, I know x equals 15. All right, so if it asked me what are the two angle measures, I would say this would be 3 times 15, which would be 45, and this one's also 45. And that would make sense because they have to add up to 90 degrees. This one as well, I see that this is a 90-degree angle. That tells me I'm a complementary. These two are complementary angles. So I know that the x for this guy and the x minus 20 for this guy have to add up to 90 degrees. So I have 2 x's minus 20. And now it's just a matter of solving for that unknown. X must equal 55. All right, so I mean I could even find, if I wanted to, the two angle measures, 55 and 35. And I just need to make sure they add up to 90 degrees. As I look at these next two examples, what I notice is they make a straight line. And so we know that that would mean that they are supplementary. So I have this nice straight line here, and the two angles, the 2x, as well as the 3x plus 25, those are going to add up to 180 degrees because that's the number of degrees in a straight line. They're supplementary. So again, we're going to do some algebra. The 2x plus the 3x plus 25 should equal 180 degrees. So altogether we have 5x's plus 25. And we need to get that x all by itself, but we need to keep the equation balanced. So as I solve, it looks like, oh, here's a good example of when long division might be helpful. It's like we got 31 there. X equals 31. So I could find the value. I could even find the angle measures. 2 times 31 would be 62, so that would be this angle. And 3 times 31 plus 25 would be this angle. 93 plus 25, 118. It depends on what the question asks. You may not have to find the angle. It may just say solve for x. So just read the directions carefully. Again, I have this nice straight line here, I know that a straight line makes 180 degrees. And so these are two supplementary angles. So I know that 4x plus 5 plus 41 should equal 180 degrees. And so now I'm just going to solve this, and I shouldn't have subtracted 41 right off the bat because what I notice is I have like terms on the left-hand side. So we're going to say 4x plus 46 equals 180. And now we're just going to solve it from there. And when I divide by 4 again, here's another time where long division might come in handy for you. Looks like we get 33.5. So in this case, we have a decimal, 33.5. All right. All right, now I see one of these crosses right here. These two lines cross each other. And that tells me that I'm going to deal with some vertical angles, okay? Or I could do some supplementary angles, but the vertical angles is what I really want to concentrate on. The angle 75 and the angle 4x minus 25 share a vertex and are exactly opposite in the same exact measure. So instead of adding these together this time, I know that they're equal. 75 must equal 4x minus 25. It's a little different than complementary and supplementary angles. Since x is here this time, I need to get the x by itself by adding 25. The inverse operations. 100 equals 4x. And finally, when I divide, I know that x must equal 25. So once again, I could find the actual measure of this 4x minus 25, but I already know it's 75 as well. So if 75 degrees is here, this is also 75 degrees. In this case, I'm guessing it would probably just ask you to solve for x. Again, I have a 90-degree angle, and that tells me immediately that we're dealing with complementary angles. I have a 2x angle and a 4x angle. Together, they should equal 90 degrees. And so this is kind of a short and sweet one. 6x equals 90, and a one-step equation to solve. X equals 15. Okay. There should be 2 more examples for you to do on your notes. We can go ahead and save those for class time. So that's it for today.